Hello students, welcome you all to this session. So here we are going to discuss about the AIET 1 JEE solutions of chemistry from class 11. Okay. So here I have selected some questions for you which are very important and the questions which you feel very difficult. Okay. So let's start from the first. The first question is to you on the screen. So it actually the question from empirical formula. And the question says, which of the following can never be the empirical formula of a compound? So basically, empirical formula always involves a simple ratio without any common multiple. Okay. So empirical formula always involves a simple ratio without any common multiple. Got it? And if you look into the options, so in option C, the compound can be written in even a simpler ratio as X, Y, Z, the whole 2. Okay. So hence the empirical formula should have actually the X, Y, Z to the base 2. Got it? So option C can never be the empirical formula of a compound. It should be XYZ twice. Option C is the correct answer for this question. Then coming to the next question, which is question number 33 of your question paper. Calculate the mass of 3.011 into 10 to the power 23 atoms of hydrogen. Okay. So we are asked to find out the mass of the given atoms of hydrogen. We know that 6.022 into 10 to the power 23 atoms of hydrogen or atoms weigh 1 gram, right? So Avogadro number of atoms weigh 1 gram. And in the question, we have 3.011 into 10 to the power 23, which is the half of the Avogadro number. It is 1 by 2 of 6.022 into 10 to the power 23. Got it? So if we take the half of this Avogadro number, we will get 3.011 into 10 to the power 23. Means this number or the mass of the given atoms of hydrogen is equal to 0.5 gram. Okay. So the half of 1 gram is 0.5 gram, right? So 0.5 gram is the answer for this question. And option D is the correct answer for this. Okay. Then coming to the next question. Question number 35. An element X has the following isotopic composition. So the given atom X is having 3 isotopes. So one is with the mass 200 and the composition is 90%. And the second isotopic mass is 199 with 8% composition. And the third isotope of X is having the mass 202 with 2% as the composition. So the weighted average atomic mass of the naturally occurring element X is close to. So we are asked to find out the average atomic mass. The average atomic mass can be calculated using one formula. It is the sum of the mass into percentage composition of all the isotopes divided by 100. Okay. So we have 3 isotopes. The mass of the first isotope is 200 and the percentage composition is 90. So 200 into 90 plus the mass of second isotope is 199 into the percentage is 8 and the mass of third isotope is 202 and the percentage composition is 2. The whole divided by 100. Okay. So if we solve this question, we will get 199.96 as the answer and it is approximated to 200 atomic mass unit. 200 AMU. Okay. So 200 AMU is given in option A. So option A is the correct answer for this question. Clear? So we just have to take the mass number and multiply that with the given composition and add all the isotopic values and divided by 100, you will get the answer. Okay. Now coming to the next question. The ratio of energy of a photon of wavelength 200 nanometer to that of 400 nanometer is. So we are provided with two lambda values. One is lambda 1, which is equal to 200 nanometer, and the other one is lambda 2, which is having the value 400 nanometer. We are asked to find out the energy of the photon. So how to find out the energy of the photon? What is the formula? The energy of a photon E is equal to hc by lambda. Okay. So from this formula, we can able to understand that energy is inversely proportional to lambda. Okay, energy is inversely proportional to lambda. So if I take the ratio of these energies, I will get E1 by E2 is equal to lambda 2 divided by lambda 1, and the value of lambda 2 is 400 and the value of lambda 1 is 200, and on solving this we will get the answer as 2. So the ratio of these energies are coming out to be 2. E1 by E2 is equal to 2. So option D is the correct answer for this question. So basically we are taking up the relationship between energy and wavelength and we are taking the ratio. Got it? It's very simple. Now moving on to the next question. A hydrocarbon is composed of 75% carbon. The empirical formula of the compound is. So basically this question is to find out the empirical formula of a compound. To find out the empirical formula, the first step we have to do is have to write the elements given in the question. Okay. We have to write the element given in the question. So what are the elements given in the question? The first element is carbon and the second element is hydrogen, because it is given like the compound is a hydrocarbon. What are hydrocarbons? The compounds which contains carbon and hydrogen only. Okay. Then we have to write the percentage composition of the each element. So the percentage composition of carbon is 75 and the remaining is hydrogen percentage, means 100 minus 75. So that will give 25. 25% is the percentage composition of hydrogen. Okay. Then in the next step, we have to write the atomic mass or the molar mass of each element. The molar mass of carbon is 12 and the molar mass of hydrogen is 1. After writing this, we have to take the number of moles. The number of moles can be calculated using the given mass divided by molar mass formula. Okay. So for carbon, the given mass, which is nothing, the given mass is nothing but the percentage composition here. So it is 75 divided by 12, which is equal to 6.25. And for hydrogen, it is 25 divided by 1. It will come out to be 25. So after getting the number of moles, we have to find out the molar ratio. So how to find out the molar ratio? So we have to look the number of moles. So we have two values, one for carbon and the other for hydrogen. You have to divide the number of moles of each element with the least possible element value. Okay. So among 6.25 and 25, 6.25 is the smallest value. So divide both the number of moles by 6.25. So 6.25 by 6.25 is equal to 1, and 25 divided by 6.25 is equal to 4. So we have 1 carbon and 4 hydrogen. Therefore, empirical formula of the compound is equal to C1 and H4. CH4 is the empirical formula. Okay. So option D is the correct answer for this question. Got it? So take the element, write the percentage composition, find out the number of moles, and take the molar ratio. Okay. So now let's go for the next. A given sample of pure compound contains 9.81 gram of zinc, 1.8 into 10 to the power 23 atoms of chromium, and 0.60 mole of oxygen atoms. What is the simplest formula of this compound? So here we have to use the mole concept. So to find out the number of moles, we need to use two formulas. So by finding out the number of moles only, we can able to get the simplest formula of the compound. Okay, because zinc is given in terms of mass and the chromium is given in terms of atoms, and for oxygen, the mole value is given. So by just looking into these values, we cannot find out the simplest formula. We have to get the number of moles for all the 3 elements first. Okay. So the formula to find out the number of moles, we have two formulas. One is number of moles is equal to the given mass divided by molar mass. Okay. So this is one formula to find out the number of moles. And the second formula is number of moles is equal to number of particles. Okay, number of particles divided by Avogadro number. And here the particle is atom. So the number of atoms divided by Avogadro number. Avogadro number is denoted by the letter Na. Okay. So using these two formulas, we can solve this question. Got it? So let me find out the number of moles of zinc first. So moles of zinc is equal to. So what is given? Mass of zinc is given. What is the mass? 9.81. Given mass is 9.81. And the molar mass of zinc, we have to study and substitute. Okay, we should know the molar mass of zinc. It is 65.39. So if you don't know this value, try to memorize the value. Okay, so the molar mass of zinc is 65.39. And if we divide this, we will get 0.15 as the moles of zinc. Okay. Next, coming to the moles of chromium, number of moles of chromium, it is equal to. So in the question, if you see atoms value is given, so we have to use the second formula. So the number of moles of chromium is equal to number of atoms, which is 1.8 into 10 to the power 23 atoms of chromium divided by Avogadro number. The Avogadro number is 6.022 into 10 to the power 23. Now if we cancel and if we divide 1.8 by 6.022, we will get 0.3 as the answer for this calculation. Okay. And next, coming to the number of moles of oxygen, it's already given. Given as 0.6 mole of oxygen atoms. Already it is given as 0.6. So, the whole molar ratio for all the 3 elements is, the whole molar ratio is equal to 0.15 is to 0.3 is to 0.6. Okay, which is equal to 1 is to 2 is to 4 ratio. Okay, so hence the formula, hence the formula is equal to, we have 1 zinc, 2 chromium and 4 oxygen. So the formula is ZnCr2O4. Okay. So option B is the correct answer for this question. Got it? So find out the number of moles and equate all the number of moles, 3 elements number of moles, and get the formula, simplest formula. Clear? So only 2 things are required. We have to just memorize the formula to find out the number of moles, 2 formulas. If you memorize those things, just by applying the formula, you can get the answer. Here. Next, coming to question number 51. The transition energy in electron volt of an electron from first excited state to second excited state for hydrogen atom approximately is. So we are about to find out the transition energy in terms of electron volts. Okay, from first excited state to second excited state, and the atom is hydrogen. So we have one formula to find out the delta E, which is the transition energy, that is equal to minus 13.6 into Z square into, open the bracket, 1 by N1 square minus 1 by N2 square into electron volt. That is a unit, okay? Unit. Now, substitute the values, 13.6 into Z is the atomic number. The atomic number of hydrogen is 1. So 1 square, open the bracket, 1 divided by the N1 value. N1 value is equal to 2. Sorry. Hydrogen is going from first excited state to second excited state. If this is the ground state for hydrogen, okay, if this is the ground state, this is N is equal to 1. And this is the N is equal to 2. And this is N is equal to 3. Okay. So this is the ground state. And this is the first excited state. And this is the second excited state. Got it? So first excited state means N1 is equal to 2. And second excited state means N2 is equal to 3. Got it? Now, N1 is 3. N1 is 3. And N2 is 2. Okay, sorry. So N1 value is 3 and the N2 value is equal to 2. So if I substitute, I will have 3 square, which is 9, minus 1 by 2 square, which is 4 electron volt. Now, if we take the LCM and if we solve this question, we will get 1.89 electron volt as the answer for this question. And we have to write the answer to the closest integer, right? So 1.89 is closest to 2 electron volt. Okay, it is closest to 2 electron volt. So delta E is equal to 2 electron volt, and that is the answer. Okay. Next, moving on to question number 53. Consider chromium atom in ground state. The sum of number of electrons with azimuthal quantum number L is equal to 1 and L is equal to 2 is. So, to find out the sum of number of electrons with L is equal to 1 and 2, first of all, we have to know the electronic configuration of chromium. To know the electronic configuration of chromium, we need the atomic number of chromium. So the atomic number of chromium is equal to 24, and the electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. So this is the electronic configuration of chromium. Okay. Now for L is equal to 1. L is equal to 1 denotes the p subshell. Okay. L is equal to 0 for S subshell and it is equal to 1 for p subshell. It is equal to 2 for d subshell and it is equal to 3 for F. So L is equal to 1 is for p subshell. It denotes p subshell. So p subshell means we have 2p and 3p. So in both p orbitals, we have 6 electrons. So 6 plus 6 is equal to 12. Okay. And if L is equal to 2, L is equal to 2. So L is equal to 2 means it denotes D. It denotes D subshell. Means we have only one D subshell, which is 3D, and we have 5 electrons in it. So it is equal to 5. Number of electrons is equal to 5. So the total number of electrons with azimuthal quantum number L is equal to 1 and 2 is 12 plus 5, which is equal to 17. Okay. So the answer is 17. Got it? So azimuthal quantum number is one of the quantum number, okay, which denotes the address of an electron and it is denoted by the letter L. So it corresponds to these values and its subshell. Okay, it gives the information about the subshell. Okay, like this, and by using this concept, we are getting the answer for this question as 17. Okay. Now moving on to the next question. The number of radial nodes in the 3p orbital is. So we have to find out the radial nodes, total number of radial nodes. The formula to find out the total number of radial nodes is equal to the number of radial nodes is equal to nodes in 3p orbital. In 3p orbital, I take in 3p orbital is equal to n minus L minus 1. So this is the formula to find out the radial nodes for any type of orbital. Okay. Where n is the principal quantum number here. Where n is the principal quantum number and L is the azimuthal quantum number. Azimuthal quantum number. Okay. Now for 3p orbital, 3 is the value of n. So n is equal to 3. And we have 3p orbital. So in the last question only we have seen L is equal to 0 for S. L is equal to 0 for S and 1 for P. Okay. So since it is a p orbital, L value is equal to 1. So if we substitute n is equal to 3 and L is equal to 1, we will get 3 minus 1 minus 1. So which is equal to 1. Okay, so the total number of radial nodes in the 3p orbital is 1. Got it? So you have to memorize this formula, which is used to calculate the total number of radial nodes. Got it? Then going for the next question. 20 ml of 0.1 molar H3BO3 solution on complete neutralization requires X ml of 0.05 molar NaOH solution. Find out the value of X. So we have two compounds. One is H3BO3 and the other one is sodium hydroxide. and they are undergoing the neutralization process. Okay, if they undergo the neutralization process, H3BO3, if it reacts with NaOH, it forms a compound of formula NaBOH 4 times. Okay. Now, we are provided with two volume. We have two volume. One is V1 and the other one is V2. And two molarity concentration term. One is 0.1 and the other one is 0.05 molar. Okay. So let me write the molarity of the first compound H3BO3. M1 is equal to 0.1 molar. And the volume of H3BO3 V1 is equal to 20 ml. So in the same way, for sodium hydroxide, the molarity is 0.05. So I'll write it as M2 as 0.05 molar. And the volume of sodium hydroxide, we do not know. That's what we have to find out. So V2 is equal to what? So this is the given information. Okay. Now, from this given information, we have to apply M1 V1 is equal to M2 V2 formula. Got it? So we are supposed to find out V2. So V2 is equal to M1 into V1 divided by M2. So M1 is 0.1 and V1 is 20 ml. The whole divided by M2 is 0.05. Okay, if we solve this, we will get V2 value as 40 ml, and that is the value of X. X ml is 40. Okay, so this is the value of X. V2 is the value of X. Clear? So it is coming out to be 40 ml. Clear for all of you? Now moving on to the next question. It is question number 59, which is the last question for this session. And the question says, a drop of water is about 0.1 milliliter. The density of water at room temperature is about 1 gram per milliliter. How many H2O molecules are present in a drop of water? Report your answer after dividing by 1.67 into 10 to the power 20. So, we have to find out the number of water molecules first. Okay. So, let me see the given values first. So, what is given? Density of water is given. So, what is the density of water? It is given as 1 gram per milliliter, right? And we need to find out the mass, right? To find out the number of H2O molecules, to find out the number of H2O molecules, we need the number of moles and the Avogadro number. Okay. So this is the formula to find out the number of moles, and that's what we are asked to find out. Okay. Now, we know the Avogadro number, but we don't have the number of moles value in the question. So to find out the number of moles, what we need? To find out the number of moles of H2O, the formula to be used is the given mass divided by molar mass. Okay. So the given mass value is not given. So instead of that, we have density value and the volume. Volume is given as 0.1 milliliter. So using the given density value and the volume value, we can find out the mass. So how to find out? Density is, we know that density is equal to mass by volume. Okay, we are supposed to find out the mass. So mass is equal to density into volume. Density is 1 gram per milliliter, 1 gram per milliliter, and the volume is 0.1 milliliter. Okay, so which is equal to milliliter, milliliter inverse gets cancelled. So it will come out to be 0.1 gram. So 0.1 gram is the mass of water. So substitute in place of mass, substitute 0.1 in place of mass divided by molar mass. The molar mass of water is 18. So how we are getting it as 18? The atomic mass of hydrogen is 1. Okay. Since we have 2 hydrogen in our compound H2O, we have to multiply 2 into 1, which will come out to be 2. And atomic mass of oxygen is 16. So we have only 1 oxygen. So 1 into 16 is equal to 16. 16 plus 2 is 18. And this is the molar mass of water. Okay. So let me substitute 18 here in the place of molar mass. So 0.1 divided by 18 is the number of moles. 0.1 divided by 18 is the number of moles. So I can take that value and substitute in place of number of moles in this formula. So 0.1 by 18 into Avogadro number. So we know Avogadro number is 6.022 into 10 to the power 23. Okay. So if I solve this, I will get 3.34 into 10 to the power 21 molecules of water. Okay. So now this is the number of H2O molecules. Now we have to find out the number of H2O droplets. Okay. After dividing the answer by the given number 1.67 into 10 to the power 20. So number of water droplets, number of water droplets or number of water molecules after dividing by the given number 3.34 into 10 to the power 21 by the given number 1.67 into 10 to the power 20 will come out to be 20. Okay, come out to be 20. So the answer for this question is 20. Okay, so what we are basically doing, we are taking the number of H2O molecules using number of moles into Avogadro number formula. So this is the formula which has to be applied for this question. Okay. Now in this formula, we need number of moles, and that I am calculating using mass by molar mass formula, and the mass is not given in the question, and I'm calculating the mass from the density and volume. So for that I am using density is equal to mass by volume formula, which we have already studied. Okay. Now after finding out the answer, we are dividing the answer by the given number in the question, which is 1.67 into 10 to the power 20, and getting the integer as 20. Okay, 20 is the final answer for this question. Got it? So here we are ending the session. Thank you so much for everyone for attending the lecture, for listening to this lecture. To meet you all in the next AIET solution paper. Okay, I hope this session is very useful and it is very clear to all of you guys. To meet you all with the next set of questions. Okay, till then, take care. Bye bye.